So let's determine any inflection values for g of x equals x to the fourth minus 18x squared. So what are inflection values? Well, those are going to be values of x in the domain of the function where the concavity of the function changes. In other words, where the second derivative goes from being positive to negative or negative to positive. So let's figure out what our second derivative is. Our function is x to the fourth minus 18x squared. That means that our first derivative is going to be 4x cubed minus 36x. And our second derivative, well, that's going to be 12x squared minus 36. And to figure out where the sign of the second derivative changes and where it equals 0, let's factor this. So let's write this as 12 times x squared minus 3. And then we can factor this further because we have the difference of two squares as 12 times x minus the square root of 3 times x plus the square root of 3. So this is going to be our second derivative. Now let's make a chart so we can see where we have any changes in sign. So here on the top, let's put values of x that make our second derivative equal to 0. Well, we have the square root of 3 would make it equal to 0, and negative the square root of 3 would make it equal to 0. So we have negative the square root of 3 and the square root of 3. We leave space on either side so that we can test values that are less than negative the square root of 3 and greater than square root of 3. And here, let's put in our second derivative, which is 12 times x minus the square root of 3, x plus the square root of 3. Now let's test a value that's less than negative square root of 3, like negative 100. If x is negative 100, what is the sign of our second derivative? Well, 12 is always going to be positive. Negative 100 minus the square root of 3, that's going to be negative. Negative 100 plus the square root of 3, that's going to be negative. So we have a positive times negative, which is going to be positive. So our second derivative is positive for x less than negative square root of 3, and it's 0 at negative square root of 3. Now what about a value that's in between negative square root of 3 and square root of 3, like x equal to 0? What's the sign of our second derivative? Well, the 12 is going to be positive. Then we have 0 minus the square root of 3, which is negative, 0 plus the square root of 3, which is positive. So now the sign of our second derivative, positive times positive, is negative. And it's 0 again at the square root of 3. Now what about for a value of x that's larger than the square root of 3? Like x equal to 100. What's the sign of the second derivative? Well, the 12 is positive. If I have 100 minus the square root of 3, that's going to be positive. If I have 100 plus the square root of 3, that's going to be positive. So we have a positive times a positive times a positive, which is positive. So we're looking for inflection values. Those are going to be values that where the concavity changes. Well, it changes from positive to negative at x equal to negative the square root of 3, and it changes from negative to positive at x equal to the square root of 3. So we have two inflection values, negative the square root of 3 and the square root of 3.